another video from Siemens PLC programming, and today we want to see the application of the T-on timer in PLC. So as you could see here, so this is actually the scenario that we want to have and the control panel that we want to design. So you have one conveyor belt which you could put box or luggage on it. These motor actually drive that, and you are able to move the box or luggage from one point to the another point. So we want to design the control panel for that. So in this control panel we have two push button, one for start, the other push button for stop. We will have two light, one light which shows the conveyor belt actually working, or that is start, and one light for stopping. So that means whenever conveyor belt is stopped, so this should be on, and whenever it is working, this start light should be on. So whenever we push the start button, we don't want to immediately start to these conveyor belts start to work. We want to have at least 10 seconds. It's wait 10 seconds. In these 10 seconds, you have these warning light working, and also these warning siren start to make the alarm and sound that people not be around these conveyor belt. So this is actually the conveyor belt that usually, definitely you saw that in the airport, in the luggage section, whenever they want to put the luggage on the belt, usually you actually hear the sound or the alarm that tells you, okay, you shouldn't be around this, it's going to be working soon. This is exactly the same thing. So again, we want to have this control panel for this conveyor belt with two push button, start push button. So this light should be on, so it's not shouldn't be start immediately. It should be takes after you push this, after 10 seconds it should be start to work, and during these 10 seconds this warning light and these setting alarm should be start to work. Then actually the conveyor start to work. So whenever it start to work, these lights should be on. Whenever this is stop, these lights should be actually on. So here you see I put the summary of that. When push start, when we push the start button, 10 second after 10 second, no, not after 10 second, for 10 second the light and siren should be on, then the belt should be start to work, and whenever you push stop push button, it should be immediately stop the conveyor belt. So let's see how we could design the ladder logic, then we are going to implement that in our PLC. So here I put the ladder logic. So as you can see here, so we have 1, 2, 3, 4, 5 actually branch which take care of the whole thing. So let's start the first one. So whatever you see here is actually exactly a 3-wire motor control, which we explained that in our previous video. So if you didn't watch that video, please watch that video. The link is in the top of the screen. So how it works? So definitely you, with this ladder logic, you have these 3 inputs and 1 output. So this stop button is normally closed, so that means if you don't push that, you have a power in this point. So then this one is normally open, so that means if you don't push, the power is stuck here. If you push the start button, you pass the power through your output, and your output has the power, or you fire your output. And this one is controlled with the same output. The reason is whenever you want to release this start push button, we want our output still will be on or 1. So as I mentioned before, this is 3-wire motor control, which we explained before. Check the link that in the top of your screen. So but here there is a small difference. So in 3-wire motor control, this output was the real output port in your PLC, but here we use actually what we call the internal bit. So that means this one is not the real physical output port that you have in the PLC. This is just internal bit that we call, we give a name, so order run. So that means whenever you push this start push button, so it is 1, and even you release, this will be actually 1 or on. So we use these internal bit later on in our ladder logic, but for now, instead of putting the physical output for that, you just use internal run, and I show you how you could make the internal bit inside your ladder logic whenever we programming the PLC. But for now, just be careful. These overrun that I use here is internal bit that I use in the program, and it is not really physical output port of the PLC. So let's see, summarize what's happened here. So if you push the start button, this overrun is 1. So even if you release, it is 1. The only time it's go back to the 0 is if you push this stop button. So push the start button, it will be 1. So if you push the stop button, that will be 0. So let's go to the next line. So the next actually line that you have here, somehow it's actually keep the stop light on. Let's see how. So whenever you push the start push button, so definitely this overrun is 1, right? So and this input that I use is normally closed. So that means whenever this 0, which means you didn't actually push the start button, so this is actually is closed. So that means there is a power E here in the stop line, and the stop light is on. This is what we want, right? Whenever the convey belt not working, so the stop light should be on, which is happening here. So whenever you push the start button, this will be 1. So if this is 1, definitely definitely this should be closed, and these stop lights will be off. So this is what exactly we want to have. Whenever you push the start button, this should be off. So whenever you not push the start button, so it should be off. So definitely this take care of these stop light that we want. Whenever you push this, after the convey belt work, it should be off, and whenever it's not working, it should be on. So these line exactly take care of that. So let's see how we make these a 10-second delay, because whenever you want to push these start, we need 10 seconds to actually turn on these 2 alarm light answering that we have. Then we start these motor or conveyor belt. We need to make that 10 second for turn on these 2 alarming that we have. So for making that 10 seconds, so definitely you need to use timer on. So see, I put the timer on here. This is a 10-second that I want to make, and the input is the overrun input, and this is normally open. And this output that you see here again is the internal bit. So this is not a physical output port in the PLC. This is just internal bit that I use in the other section of these programs. So let's see what's happened here. So whenever overrun is 1, so that means whenever you push the button, this is 1. So if this is 1, this is actually closed. So you start to count 10 seconds. This is what we want, right? Whenever we push the button, we want to actually somehow able to make that 10 second and able to turn on our alarms in that 10 second. So somehow these line here make this or measure that 10 second or keep that 10 second for us. Whenever you push the start button, this is actually trigger the timer start to count from 0 to 10. So after 10 seconds, it's actually turn on these internal bits. So that means T on bit will be 1. So let's see what we should do in that 10 seconds. So definitely in that 10 second, after 10 seconds, what should be happen? So this is tells these line tells what should be happen after 10 seconds. So again, this is a normally open. So that means if you are in that 10 second, so this is open. So that means the conveyor not working, no power on the belt, on the motor, and also no power on the start light. So that means both will be off. This is what we want. In that 10 seconds, we want to just turn on our alarms and no belt working and no start light working. That won't take care of that. So what should be happen? This is actually for after 10 second. How about during that 10 second? What should be happen? So during that 10 second, the alarm should be start to work. So this is that these line take care of that. So see this. So these you have the overrun. So that means whenever you push the start button, definitely this is actually closed. So you have a power here. So then this control, these normally close control with T on bit. So what it tells to us. So this is normally closed. So that means whenever you are in that 10 seconds, so this one is closed. So that means during the 10 seconds, the power actually passed through the both of them and fire the warning light that you have and also the siren that you have. So that means during that 10 second you will be have the warning light is on and also siren got the power and you have these alarm. So see what's happened after that 10 seconds. So that means whenever the 10 second is over, so definitely this will be 1. So if this is 1, so this should be actually open. So that means you have no power on light, warning light, and the siren. So that means after that 10 seconds, the both of them is off. So as you could see here, so with this ladder logic, you actually able to do the job. So here, definitely you should set up some physical input and output. So what we are going to do in the TIA portal for the PLC programming. So I'm going to use these ports. For the start push button, I use input 0. For stop push button, input 1. So as you could see, we just need to input start and stop push button. So how many outputs do we have? So we have one output for start light for turning the start light. So I put in the output 0, stop light in the output 1. Warning light definitely should be the physical output. So this is in output 2. So the siren should be the other output. It is on output 3. And the conveyor motor so definitely is should be another output which we put in output 4. So as I mentioned before, these overrun and T-on bit, they are not the physical output, they are just internal bit. So how you could make that in the PLC, you will see that you need to just put these inputs, that means normally open, or here these output, and instead of you to double click on the tag, so then right click, rename the tag, and then you could actually use these percent %m 0.0 means this is actually the internal bit number 0. So this is internal bit number 1. So using this percentage %m 0 point, you could actually make any internal bit that you need. So which we use M00 for overrun internal bit and percentage M01 for T-on. I will show you that in the TI portal the same thing. So this is actually about the ladder logic, and the ladder logic that should take care of the scenario that we have. So let's move to our portal. So this is a TI portal, so I'm not going to somehow do everything from the scratch, because I already in the previous videos I explained how you could open the make a new project, set up your PLC, and how you could go to the program blocks and make these ladder logic. So whatever I already did that. So I already did that, and you see the scenario that we have. So this is what you see on the screen right now. I actually turn this off. Go to the, okay. So what you see here, so even if I could zoom that a little bit, so see, this is exactly the same logic that we have, okay? So this is exactly the same thing that you saw and I explained here. So I just go, because again, because I want to save our time, I don't want to make this video too long. So I am not showing that part because we already did in the all previous video that you have, and in this level you should be easily actually implement any ladder logic in TIA portal. So you implement this on the program blocks in the TI portal. So just let I put these back and just review few things here. So as you could see, as you could see, and I explained here, I actually exactly follow the same um, input and output port based on what we have here and what I explained here. So as you could see, my stop push button is on the input 1. So start push button is in input 0. So this is overrun. This is actually how you could make internal bits. Let I show that again here, just in case if you don't get what I explained before. So see, for example, you want to make one internal bit like this. So this is output. So you actually put these here. This is the same thing that usually you do. Let's see what it put that there. That should be there. Let's just undo that. Okay. So let I see. Let I do this. Let I bring one here and put that one here. Okay. So now you want to make this internal bit similar with this. So if you click on this, let me see, to double click on that, and if whenever you double click on that, you just say uh, percent percentage m 0. So see, I already make 0 m00, which is for my overrun, and the next one is for t on bit. So let's do make number 2 because I already make 0 and 1. So let I say 0.2. So which is whenever you say percentage m02, it means the internal bit number 2. So whenever you actually type that, so it's give a tag name. If you want to change the tag name and have this overrun, so you just come here, right click, say rename it. So then give any name that you want. I don't know. So for example, override, whatever you want, okay? So then you say change. So it's a change to the override. So I did exactly in the same way for both of them. So this one is the same process. You just put these here, then actually type m%. I redo that for you. So let I just go back here. I don't want to kill what I did before. So let I show how I actually make this one. So again, you should be knowing this level, how you could make that easy. Just put that here. So click on this, double click, just type again percentage m 0.2 because I deleted that 02. So then you have it. So for making the name, you go to the rename tag and give hello whatever you want. So easily you could actually have that internal bit, which will be the normally closed switch. So I'm going to one step back and somehow get rid of them. Okay, so that means easily you should know how I made these internal bits. So let's review that fast. So this is actually port input 1 for stop push button. So the start is in port 0. So this is internal bits, which I show you how you could make that, which we call that overrun. And this guy here is the normally open, which is controlled with this one that you have. So let I show this how you could make some this one too. Let's do that here. Okay, so I click on this, add this here. So I want to just show how you could control this normally open with these internal bit that you have. So you actually put these here. So then you should be able to close it. Let's see. Yeah, probably you could close like this. Okay, it's closed. I don't know why it should be closed with this, but it doesn't like that. So yeah, how you want to control these. So see, I want to show you how I made this. I want to have these input which control with the internal bit. So I'm making the same way in the normal way I did. So then if you click on that and if you push here and type percent, it's keep actually bring you the old tags that you already have. So see M00 is here, M011 is here. If you choose any of them, so easily you could have this which control with the internal bit M00. So this is actually give you idea how I made that. So let I go back and get rid of all things that I made. Okay, so now better. So this is we explained this and you should be easily able to implement this. So then this one is controlled with this. I show how you could do that. Again, you just need, if you even go put these here and type percentage, it give you a list of the tags that you have. You just select this one. So this stoplight comes to the output 1. So again, if you want to remember, the order is 2. So the stoplight is O1. Okay, I actually follow the same thing. So again, this one control will overrun, which I show you how you could make that. So this timer we talked in the PLC timer video how you could bring that. It is here. You go to the instruction and drag and drop these T on there. Okay. So you should be fine with this. So this is another internal bit which we call that T on bit. It is M0.1. So you know how you could make that. I already explained it to you. And finally, we have these two last lines. So again, this T on again is your internal bit. So the conveyor, which is the motor of your belt, is on output 4, and the start light is in output 0. And finally here, these two is internal bits. And again, the warning light is on output 2, and the siren is in output 3. Exactly match with what I put here. So here you could see the summary of them. So now let's see is it working or not. I already compiled that. Let's see could I go to the online mode or not. So if not, I probably need to compile that again because I made some changes here. No, it's not working. So let's do that again. So I'm coming here, compile the everything that I have. So then yeah, it's working now. So let I load that again just in case. So I load it to the PLC. It says, you already have? Do you want to override it? I say yes. So it's actually is going to load that. So now let's see. Yep, now it actually goes to the online mode that we have. So let's see what's happening online mode. So let I give you a one view of the PLC here. That means you'll be able to see in the same time what I'm doing here, and also we check here. So what we have here, so see these two switch that I have is for PLC switch. So this is actually the start button, this is actually the stop button. So, and the both of them, as you could see here, I put some label which should be easily, you should be see this. The first LED shows the input 0, which is start push button. So the one is stop push button. Here in the lights, the first one is the start light, the second one is the stop light, so the third one is warning light, the fourth one is the siren, and the last one is conveyor. So that means we start from 0 to 4, which is totally 5. So now I'm going to just put the stop button for a short time. So let's see. I push the stop button. So what you expect to see? You are in the stop button. So that means the stop light, which is this, is on. Okay, this is what you expect. Okay, that's fine. So now, and here even you see whenever you have in the stop and you just like push the stop button for a short time. So this is what happens. So the overrun is off. The only thing here in this ladder is on. You see all of them is off. The only thing is on is the stop light, which is the output 1. So that is here. Okay. Now, what we should want to happen, if I push this start button for a short time, okay, so what you expect to see. So if I push this, what should be happen? I should have the 10-second, which is the warning light, and the siren, which is these two lights. It should be on for a 10-second. So after 10-second, the conveyor should be start to fire, and also the start light, which is this first one currently is off. It should be actually on. So these two should be on for 10 seconds for the warning light and alarm, and then conveyor and the start light should be on. So I'm going to just trigger the first input and see that's happened or not, just for a short time. So see, now the siren and the warning light is on after 10 seconds. It should be go to the conveyor is on now, yeah, and the start light. So see, this is again conveyor is on, and this is actually on, so it just shows the start light. So it's working. So I'm doing that again. So see, I'm pushing the stop light, stop push button for a short time. So see, it goes to the stop. So now stop light is on. So now I push the start button, so the alarm light and siren is on for a 10-second. After 10-second, conveyor should be on, and the start light. See, now it's a moment. So see, now start is the conveyor is on, and also start light again. So I'm pushing this stop, so it's going to be stop light is on. So then if I push this start again, the two alarm that we have, the siren and the light is on for 10 seconds. After 10 seconds, so the start light should be, yes, that's the moment that we have. So I show you, let I back to here, you could see in the start mode too. So see, right now I'm in the stop, the only thing is on is the stop light, even you see on the PLC. So now whenever you somehow push this start button that we have, this guy should be on. So whenever this is on, immediately these guys should be start to count. So see this. So I'm pushing that, this is on, this is start to count. Take a look this. So then after in these 10 seconds, these two is on, right? On. So then it is on, so the conveyor and the start light is on. That's really cool. That's really cool. So let's do that again. So the one thing that you should, so see again, this is in the start mode. So you have these two is on, and also the start light is on, which is with the conveyor is on. Okay. So one other thing you could do, so see whenever I push the stop button again, so let's go to the stop, and the one thing I want to show to you, whenever I put this start, so this is 10 seconds, so the both alarm light is on here, so you could see that. So then after 10 seconds they should be conveyor on and the start light, which is now you see these on. So see, even in whenever this is this working, even if I push the start button, it's not actually do anything. Okay, this is based off the 3 wire that we have. So even this is off, because of this, your actually conveyor is on and easily it's working. So just check that for the last time. So we put this stop, it is actually stop. So maybe this time it is better to take a look what happened here. So we are in the stop button. So the only light is on is the stop light. So whenever I push these start, just see two things. So these two should be on immediately after I push this start. Okay, I'm going to push this start. See this. So see, they are immediately on, and this timer start to run. So it's measured 10 seconds after that. These two should be off. The rest should be on. So see, after 10 seconds, these two is actually off and this one is on, which is same thing happen here again. Stop it. I started the setting and the light alarming light is on. So after 10 seconds, it's actually moved to the, which is now is actually the start light and come here. So this is what we have for today, which somehow shows the application of T on. I hope you like this video and see you all in our next video.